So I'm going to show you how to find the angle between two curves, and I'm going to be using my TI-83. The display on it looks different than the TI-84 when you go to taking derivatives. Okay, so when we do this, remember that m's, or these actually stand for the slope. And in this case, it's going to be the slope of the tangent line at the point of intersection of your two curves. So this will be the slope of the tangent line of one of the curves at the point of intersection, and M1 will be the slope of the tangent line at the intersection point on the other curve. Okay, so this is the formula we're going to be using to find the angle between the two curves. So the first thing I need to do is I go over to my calculator and I need to type the two equations into the y equals menu. So I just press the y equals button. I'm going to do x squared minus 1. And then the other equation is the square root of x minus 0.5. Okay, and put it in parentheses for the end of my square root. Okay, let's just look at zoom standard. So I'm going to hit the zoom button and we're going to choose standard. Remember, this gives me from negative 10 to 10 on the x and negative 10 to 10 on the y. Okay, so the first thing I need to do is find the intersection point, which is about right there. So to find it, hit the second button and then the calc button, which is on your trace button on your buttons across the top. Okay, so it's just second calc, and we're going to choose number 5, which is intersect. Oops, hang on, I gotta go down one more, sorry. Okay, so I'm going to intersect, press enter. Okay, it's asking for the first curve, which if you see up here at the top, it shows me that I'm on Y1, so I want to press enter. Okay, then it asks me for the second curve. Okay, so here, and sitting on Y2, you notice if I press enter, which I'm actually pressing enter, nothing's happening. You see down here, you're not actually on the second curve because there's no y value. Okay, so when I was on Y1, it was sitting actually right here where x was 0. And if you notice your second curve, there is no graph for that square root graph at that value. So all I need to do, if you look here, x equals 0, I'm just going to scoot over until I actually have some y value. Okay, and you notice I just hit the right arrow key is all I did. I'm still on Y2, so press that as my second curve. Okay, and then it's going to ask you for the guess. So I'm just going to move my cursor up so it's sitting at about where the intersection point is. Okay, and then I'm just going to press enter, and then that'll give me my guess. Okay, the only thing I'm interested in is the x value because I'm looking for this derivative of each of these two functions at that point. So it's when x is about 1.4 or so. Okay, so next step is I'm going to do second quit. Okay, just so I don't have to keep typing that number in. Okay, remember it's actually stored over here in x. So I press x, press enter, and you'll see that same value, okay, that we just found. I'm going to actually store that in my a, just so I don't end up losing it. Okay, because if I go back to the graph, x is going to become something else. Okay, so I press the X button, and then there's an STO button right above the on button, and then the alpha A, which is actually on the math button. Okay, and then I'm going to press enter, and all I did so far is put that number into my variable A. You could have picked any letter that you wanted. Okay, so the next thing is I got to find the derivative of each of these values at that point that I just stored into A. So I'm going to press the math menu, and it's number 8 in your list. Okay, where it says n derivative. Okay, so press enter, and I'm just going to go here. I'm just going to write what you have to type in on your screen when you do this. Okay, so the command is n deriv, which means you're taking, what we're actually going to do is just take the first derivative. Okay, you need to tell it what function you're going to be using. Okay, so I lost where it was. My function will come first, and then I'm going to press the comma, and by the way, the comma is on the key above the 7. Then I have to tell it what variable is in your function. Okay, and then the last thing I have to tell it is the value that that variable is going to take. Okay, so it goes, once you get the command in, a beginning parentheses, you tell it what the function is. You tell it the variable, this is, in my case, is going to be x, okay? And then you tell it the value that that variable is going to take. Okay, so now if I go back to my calculator, okay, remember that your function is in Y1. So to get to y1, I'm going to, in this case, I don't want to press the y equals button because I want to actually put y1 there. So I'm going to go to the VARS button, right, which is right below your down arrow key. Scoot, so press the right arrow key so you're over to y-VARS. We're working with functions, so press 1. And then you have, there shows all your different functions, and my function is y1, so I'm just going to press enter or press the number 1. Okay, and then it'll take you over. Now we need the comma, which is above the 7. The variable in that function, remember we actually used x because we have to when we're on the y equals button, so my variable is x, and then the comma, and then I need to use that 1.395 number, because remember I stored that in A, so now I'm going to press alpha A. Okay, and then an end parentheses for the ends. Okay, so now once I do this, I'm going to now press enter. And it'll tell me the slope. I'm going to actually call, I'm going to lose my window there for a second. We're going to call this number 1. Okay, and this one here I'm going to call number 2. Okay, so M1 is equal to that number I just got over there, which is about 2 point, oops, sorry, hold on. So M1 is equal to 2.79. Okay, and now I got to find M2. Okay, so that's the slope of the tangent line at the intersection point for this curve. The format's the same. The only thing I need to do in this case is change where it says function to make that say y2. So back over to my calculator. I'm just going to retype that line. I don't have to retype the whole thing. I'm just going to press the second button and then the enter button, and it retypes that line for me. Okay, so once it's retyped, just use your left arrow key, go over to, so you're sitting on top of y1, and we need to change that to y2. I'm going to do it the same way as I got the y1 there to start with. So I'm going to hit the VARS button, the VARS button with V-A-R-S, right? Scoot over to where it says y-VARS. Okay, and then number 1 for function. And in this case now I want y2, so either just press the 2 or make sure you get the y2, press enter, and it will replace the y1 with a y2 when you get over to your other screen. Okay? Okay, everything else stays the same, so I'm just going to press enter. And it'll tell me this, what the slope of the tangent line at the intersection point is for the second graph. Okay, so this will be 0.5285. Okay, now I need to plug these two numbers into this formula here. Okay, so back over to my calculator. Okay, and we're going to do parentheses because we're going to have an operation, a subtraction in the numerator and a subtraction and an addition in the denominator. So I'm going to have to put the numerator and denominator in parentheses. Okay, so that'll be 2.79. Oops, let me do it the direction I have them. So parentheses. Okay, if you don't want to type that 0.5285 number, and it's actually my previous answer, so I'm just going to do second answer. That's M2, right? Minus M1, which is 2.79. Just so you know, it doesn't actually matter which you call M1 and M2, okay? You're going to end up with a different sign on that answer when you're done, but since you're taking the absolute value, it doesn't matter. And then divided by, and don't forget your parentheses around your denominator, so 1 plus M1, which is 2.79, times M2, which I can just use answer, which is just press second and the answer key is on the negative, and then an end parentheses for the end in my denominator. Okay, now when I press enter, that gives me this part of the fraction. Okay, now you notice it's negative. I want the absolute value of that, so I actually need to make it positive. I can make it positive just by using negative of the answer. So we're trying to find the angle, so I need to do second tangent, right? Okay, and then we're going to want negative of that answer that I just found. That way it'll make it positive. And the reason we need it to be positive is because I want the acute angle between the two curves, and if I make it positive, it's actually going to give me an answer in the fourth quadrant as a negative angle, which isn't going to help me any. Okay, so then when I press enter, right, I get about 42.4 degrees. Okay, so come back over here. So that tells me that phi is, what did I say, 42.4. Okay, now what did we actually do? Let me grab my graph here. Okay, so here's the graph. It's a different window than we had done on my calculator. And I actually had it put in the two tangent lines here at the point of intersection. So here's my point of intersection. The blue line is the tangent line of y equals x squared minus 1, and the red line is the tangent line of my second graph, which is a square root graph. Okay, so what I ended up doing is I found the slope, I found the slope of each of these two lines. When I calculated phi, it gave me the angle in between those two lines. Okay, so what I found was this angle right here. It's always going to give you the acute angle, not this obtuse angle, which, if you know, remember about vertical angles, right? This angle will be the same angle. Okay, so it gives you the angle between the two curves at the intersection point of the two curves.